Okay, for this problem it asks, a car traveling at 67 kilometers per hour hits a bridge abutment. A passenger in the car moves forward a distance of 59 centimeters with respect to the road, while being brought to rest by an inflated airbag. What magnitude of force, assumed constant, acts on the passenger's upper torso, which has a mass of 46 kilograms? So, let's start out with the drawing. So, in this drawing, we can see the car going into the bridge abutment, and it's going at that at 67 kilometers per hour. And then once we go inside the car and we look at the person, once they're hitting the airbag, it would be a distance of 59 centimeters. So now let's go to the given. So for the given, the final velocity is 0 meters per second because once the passenger hits the airbag, they come to rest. Then for the initial velocity, since what the car is going at, it would be 67 kilometers per hour. For time, we do not know. For distance, it would be 59 centimeters. And then we're trying to find the acceleration in order to find the force. And then for mass, it would be 46 kilograms. Okay, to be able to solve for the acceleration, we need to do some unit conversions. So we have first for the initial velocity, it is equal to 67 kilometers per hour. So let's start off with hours. So 1 hour is equal to 3,600 seconds. And then now let's go to kilometers. 1,000 meters is equal to 1 kilometer. And if we just solve this, it would be 18.6 meters per second. Now, we also have to solve for the distance so that it will be in meters. So, the distance right now is 59 centimeters. So, in order to convert that, we just do 100 centimeters is equal to 1 meter. And then once we solve, we get that it is 0.59 meters. Okay, now we can solve. Let's use the second kinematic equation to find it. So, VF squared is equal to VO squared plus 2A delta D. So, from our given, we know that the final velocity is 0 squared, that the initial velocity that we just found was 18.6 squared. And then we have 2a, which we're trying to find, times 0.59. And once we do the math there, we should find that the acceleration is equal to 293.9 meters per second squared. And if you're asking here if it should be negative, it's not negative because at the top it asks for the magnitude, which means that it's always positive. So to make this easier, let's just make sure that the acceleration right now is 293.9 meters per second squared and not negative. Okay, going on to our final part. So, F is equal to MA. From what we've already gotten from our given, M would just be 46 kilograms. Times the acceleration we just found, which would be 293.9 meters per second squared. And solving this, we would find that the force would equal 14,401 newtons. So, in order to check this, we could just do F equals ma again. So, let's plug in F, which we just found was 14,401, is equal to the mass, which was given, which was 46 kilograms. and times the acceleration so we can check. And if we do the math here, we should find that the acceleration, again, is 293.9 meters per second squared. So, again, let's check through our other work. So, once we do this, from our given, we can tell that we did the right thing. The only thing confusing might be whether it is negative or not. But just finding from the magnitude, it would not be negative because the force has to be positive. So even if we use a negative acceleration, it wouldn't be correct. Then going through our unit conversion, everything seems right. So I think we just solved the problem.